Today you will graph quadratics that are written in vertex form. So in the past we've been graphing quadratics that were written in standard form, and now we have a different form that the equation is going to be in. The math practice that we're going to focus most of our attention on today is a 10 to precision. And this is because this formula, the numbers are in different orders, and we have positives and negatives that we have to be very careful with. And so our biggest thing in this unit or in this section is to just be very careful with our work and to really focus on what we're doing. So to start with, let's review about standard form first. So standard form of quadratic functions is the form y equals ax squared plus bx plus c, or if you write it in the function notation, it's f of x equals ax squared plus bx plus c. So the first part says how to tell which direction the quadratic opens up. So to know which direction the quadratic opens up, you look at the a value. If the a value is positive, then the graph looks like this. That's a graph that opens up. If it's negative, if the a value is negative, then the graph looks like that. That's a graph that opens down. Now, how to find our axis of symmetry? Well, to find the axis of symmetry, you need to find negative b over 2a, and then that's going to be your x value. And then finding your vertex. Well, the vertex is a point, and the x value of that point is negative b over 2a. And the y value, you're going to plug the negative b over 2a, you're going to plug that x value in for x to the equation to find your y. So in other words, we're going to substitute negative b over 2a into the equation for x and solve for y. Now, how to find the y or the x-intercepts? The x-intercepts are where y equals 0. So we're going to substitute 0 for y. Or in other words, we'll set the equation equal to 0. Now, when we do this, we always need to, when we solve the equation, we either need to factor or use the quadratic formula. Now to find the y-intercepts, that's when x equals 0. So we'll substitute 0 for x. It's always going to be the c value. So whenever you substitute 0 for x, the answer you get is always going to be c. Now, how to find extra points? You're going to choose values for x, and you can do that by looking at your graph and seeing where you need some points filled in. You're going to substitute substitute a value, any number for x, and then to find the y values. So you'll solve for y. So that's all old news. We've been working with that for a while. Now the new thing that we're going to do is the vertex form of a quadratic function. So the vertex form is this. Y equals A times the quantity, so in parentheses, x minus h in the parentheses squared plus k. Y equals A times the quantity x minus h squared plus k. And this is where the point h, k, is the vertex. So this is why it's called vertex notation, because it actually gives you the vertex. The a value is the same a value that we have in the standard form. And then, of course, the x and y are just x and y. They're the variables. So one thing that I really want you to make sure you're paying attention to is this h is a negative. It's a minus. It has a minus sign. And the k has a positive sign. So notice that the h is negative and k is positive. No, I don't want you to think of h as being negative. I want you to think of h as being the opposite. So when you have numbers substituted in for a, h, and k, if you have x minus a number, then that means your h is positive. If you have x plus a number, then that means your h is negative. So let's go through and let's answer these same questions, but let's answer them about vertex form. So how to tell which direction the quadratic opens up? Well, you're still going to look at the a value. That a value is right there. So that a value is still going to tell us which direction it opens up. So once again, if it's positive, it's going to look like that, which means it opens up. If it's negative, it's going to look like that, which means it opens down. How will you find your axis of symmetry? Well, remember the axis of symmetry is the x value of the vertex. So if our vertex is hk, then our axis of symmetry is just h. And then our vertex, of course, is hk. And once again, make sure you're really paying attention to your signs. You're taking the opposite of what you see h to be in the formula or in the equation that you're given. Now, how to find your x-intercepts. There's no magical way to do this. It is actually the same as with the standard form. So you're still going to substitute 0 for y, which means you're going to set the equation equal to 0. So you're substituting 0 for y. You're setting the equation equal to 0. Now our equation is in a different form though. So we're not going to factor or use the quadratic formula. Instead, we're going to have to go through and we're going to have to solve it in a different way. We're going to solve it in the same way that we solved equations in Unit 1. And we'll do an example on the back of your note sheet in just a minute. How to find the y-intercepts? Same thing. The y-intercepts, you have to substitute 0 for x because it's still where x is equal to 0. And when you do that, you actually are going to have to do a little bit of work on this one. It's not just going to be the c value. And then how to find your extra points? Well, you're going to substitute the value of x to find your y values just like before. So these last three things are the same. You're just going to go through solving a little bit differently. And you can also, remember, you can also reflect over the y or over the axis of symmetry as well. So let's go ahead and move on to the back of this and let's do an example. When we're doing this, don't forget that you need to have your axis of symmetry. You need to have your vertex. You need to have your x-intercepts, your y-intercept. I want 5 total points on your graph. And then you need to have your domain and range. Now you're no longer going to be given this list when we have homework, tests, and quizzes. So you need to start remembering those on your own. You need to remember to find the axis of symmetry, the vertex, those intercepts, have 5 total points, and then put domain and range. We've done enough problems that at this point it should be coming pretty natural for you to do all those things. But if you need to, study this list and do as many problems as you need to until you really remember these. So let's go through and let's start with axis of symmetry. Well, this is written in vertex form, so I know that my axis of symmetry is that h value right there. Now remember, it's the opposite of that, so since it's x minus 3, the axis of symmetry is a positive 3. So on my graph, I'm going to go ahead and put my axis of symmetry along the 3. Next, I'm going to do the vertex. This is written in vertex form, so I know that my vertex are those points right there. So my vertex is at 3, 4. So I'm going to go ahead and put that on there. Next, I need to find my x-intercepts. To find my x-intercepts, I set this equal to 0, or I substitute 0 for y. So I have 0 equals negative 2 times the quantity x minus 3 squared plus 4. And now when I go through and solve this, my first thing I need to do is subtract 4 from both sides. So I have negative 4 equals negative 2 times x minus 3 squared. Now you're going to go through this same process every time you're solving this equation. You're going to subtract that k value. Then you're going to divide by the a value. So you have 2 equals x minus 3 squared. Now at this point, I have the whole side squared, so I need to square root both sides. When I do this, I'm square rooting to solve an equation, so I need to remember my plus or minus. So I have plus or minus rad 2 is equal to x minus 3. And then I need to add 3 to both sides. So I end up with 3 plus or minus rad 2 is equal to x. Well, the square root of 2 is, that's not a perfect square, so I kind of have to estimate this. I can either estimate it in my head or I can calculate it out. But I do know that my x-intercepts are going to be 3 plus rad 2 and 3 minus rad 2. Well, if I think about the square root of 2, I know that that's between 1 and 2. 1 would be the square root of 1 and 2 would be the square root of 4. Well, the square root of 2 is closer to the square root of 1 than it is to the square root of 4. So I know that this is going to be maybe 1.3 or 1.4. So I'm just going to think to myself, 3 plus 1.4 is 4.4. And then 3 minus 1.4 is about 2.6. So that's about where my x-intercepts are. I do know for sure that it's between 4 and 5 for my first one. So it's somewhere between 4 and 5, so I'm going to put it about there. And then it's somewhere between 1 and 2, so I'm going to put it about there. They're not going to be exactly perfect, but if they're in about the same spot, that'll be fine. Next, I need to find my y-intercept. So to find my y-intercept, I need to set x equal to 0. So I have y equals -2 times the quantity 0 minus 3 squared plus 4. So y is equal to -2 times -3 squared plus 4. So that's -3 squared is -3 times -3, which is a positive 9. -2 times 9 is -18. So I have -18 plus 4. So y is equal to -14. Now my y values only go down to -10. So just for the sake of having a decent graph, I'm going to go ahead and just estimate where -14 is. So I have -10, -11, -12, 13, 14. It's going to be somewhere around in here. Now that I have my axis of symmetry, my vertex, and my intercepts, I need to make sure I have at least a 5th point on there. So I have a couple options. If I want a point that is on this graph, I can figure out for either 1, 2, 4, or 5. Or I can go ahead and just reflect this y-intercept. And that's what I'm going to go ahead and do. So a 5th point is going to be about right here. And so now, when I connect these, I'm making it a curve. I'm putting my arrows, and I'm doing my best to make sure it curves at the vertex. And so here is about what my graph should look like. Now once I have it graphed, I cannot forget my domain and range. So I need to go down here and I need to say my domain is always -infinity to infinity. And my range, remember I'm going from the bottom up, so it starts down at -infinity and it goes up to a y value of 4. So my range is -infinity to 4. Now that is all for this section. You have homework where you have to do these problems. On the homework, you are given 5 graphs and you have to do at least 4 of them. The only thing is you have to do the very last graph. Even though it doesn't quite look like it, that is written in vertex form. So think about what your A, H, and K values are for that last graph. Other than that, that is all for this section. So of course, if you still have any questions, come talk to me.